Okay, so now we have this four cardinal direction based animations, right? uh, yeah, so we have this small issue where if I am try to change the direction, it will start to play pivot animation, but it doesn't jump back to the cycle state, right? Okay, so this is a bug that we have to fix. So maybe let's try the left cardinal direction pivots as well. Yes, for that as well, it has the issue. Okay, so let's fix that real quick. So inside the anim graph, locomotion, so we have jump from pivot to cycle, right? At here. So we have the first one, which is standard blend. Okay, so let's look at what it does. So if the anim set is changed, we make a transition from pivot to cycle, which is fine. And then we have the second rule where we check if we have a movement change or we are moving to the perpendicular to the initial point, then we are making a transition, right? Okay, so maybe let's disable this pin and try to connect this one. Compile and save. Let's play it again. Okay, it still seems it doesn't jump back to the cycle state. Okay, let me see again. Yeah, so what we can do is we can make an automatic role based transition from pivot to cycle, right? So whenever the pivot cycle animation has been played, once it ended, it automatically should jump to the cycle state, right? So it will prevent like halting at this pivot state. Okay, so this transition I'll make the priority as 3, and it should be automatic rule based transition, right? And then inside the pivot sequence machine, state machine, we have this pivot transition, pivot state. But what if we add another pivotal change? So in the current system, if I make a pivotal change, yes, now it go back to the cycle state, which is fine for forward and backward, right? It works properly. But let's say if I'm change the direction to the left to right, it seems left to right pivot is different, right? Do we have the correct pivots at jog? Pivot cardinals, forward, backward, left and right. Yeah, it may happens because it currently remaining at this state, and whenever we made the state transition, it may not jump to the proper pivotal state. How we can resolve it? So the pivot is same inside this sequence state. We have this sequence evaluator to set up the pivot, right? This is the place we set the NA, which is fine. And let me see real quick. At the update, we are simply advancing the time, which is again fine. But I think maybe we can make improvement here. So do we capture the last pivot time? Right. So maybe we need to capture it. Let me see. Okay. Right. So the setup pivot denim layer, let's create a new variable called last pivot time, and I'll convert it to a float, and let's move it to the locomotion SM date. And at the setup, I'll mark it as 0. Right. And yeah, let me quickly look at my documentation. Yeah, so let's go outside of the state machine, and we have this setup pivot state to capture the pivot initial direction. Similarly, let's add on update binding as well, and I'll rename this function as update pivot state, and this is a state node function. Inside the state node function, let's get the last pivot time, and if it is greater than 0, which means we have properly captured one, then let's reduce this further. So at the context, let's get the delta time, and let's set the last pivot time again. Okay, now we have captured that last pivot direct time, right? Then what we can do is, let's go back to our pivot state machine, pivot, and update pivot denim layer, and there set a sequence, and first let's check whether we have a last pivot time. Right, so if we have a pivot time for a short period of time, we may able to show a pivot. Right, so we have this pivot cardinals. Let's split it, and we have this cardinal direction from acceleration. Based on that, we can make a selection for each direction. And then I'll promote this to a variable, maybe as a local variable called new desired sequence, and attach it to here. So now we have to check based on our sequence evaluator whether we have different pivotal animations. So first I'll promote our sequence evaluator reference set here. Yeah, maybe I can use this one and promote this to a local variable called sequence evaluator. And then let's check whether this one is not equal what the sequence evaluator is currently playing. Right, if it is not equal, then we can play our new desired sequence. So let's get the context and the sequence evaluator instance. Let's set sequence with inertial blending in this context. The new sequence would be a new desired sequence. Right. Compile and save. Let's try to play it again. Yep. We have that pivotal change. But for the left and right movement, actually, still the pivot is wrong. Right. So in order to fix that, I think maybe we have to add some bidirectional state transition. So let's go to the pivot state machine, and I'll add a new state called pivot B. Right, and I'll rename this one as pivot. Okay, and at the pivot B, actually we have to add the exact same sequence evaluator that we have at the pivot A. So I'll copy that thing and go to pivot B and paste it there. Okay, and as the transition rules, we can go there and let's check a few stuffs. Right, so first you can get the local velocity 2D and the local acceleration 2D. Let's get the dot product and check whether it is less than 0. And let's get the property access pin, and there actually we can get that is moving perpendicular direction. Do we have such variable? Is moving, yeah, let me see. We have a function called is moving perpendicular to initial point. Yeah, this one, and not boolean. So either this one is true and this one is true. Plus we need to capture the pivot starting acceleration as well, and I think we have no reference to it. Let's see it again. Pivot starting we don't have it. So I think the pivot A, the setup pivot anim. Before setting the sequence, let's set a new variable called pivot starting acceleration, which is vector, and this is a locomotion state machine data, and I'll set it with local acceleration 2D at the initial setup pivot anim layer, and at the updating pivot anim layer, at here we can update it accordingly. Pivot start acceleration, get local acceleration 2D. Okay, now we have reference to this variable set. Let's go back to the this pivot, this transition, and there let's get the local acceleration 2D and pivot starting acceleration, go dot product, check whether it's less than 0, and let's set the third condition, right? So basically we are checking the local acceleration dot products and local pivot starting acceleration dot product, and we are checking when we are not moving to perpendicular to the initial point. So if 3 of these conditions satisfies, we can make a transition. Compile, go back, and for the since this is a bidirectional jump, maybe we can mark it as a promote this as a new shared transition rule. So I'll promote it to shared and give it a name called wants to repivot, and as the outgoing edge I'll use the same transition, and I can make this as initialization, and this one is also initialization. Compile, save, and now let's play it again. Okay, yeah, still I think we have sort of a pivotal issue, but I think for the forward and backward direction now the issue has been resolved, right? Okay, yeah, so I debug it further, and I think the issue is at this one, the cardinal direction from acceleration. So what we can do is we can replace this stuff by using our local velocity direction, right? So the local velocity direction is actually pointing to a correct variable, correct direction, because if I try to, so at the event graph I actually try to debug this cardinal direction from acceleration. So when I am moving forward, it print in the backward, which is wrong actually, and forward, right, left. Actually it happens because we try to invert this variable at a different function. If you remember it, at the update acceleration data, actually we are trying to invert it. So if I try to connect it like this and try to play again, now it works properly, but still for left and right sometimes it doesn't work correctly, because seems like it's not updating instantaneously, right? It will take some time to be updated. So as a workaround, what we can do is something like this. Right. So let's go to the event graph, and instead of using this one, let's use local velocity direction. Let's try to print it. Yeah, now you can see it's giving a proper cardinal direction. That is what we want, right? So go back to this function, which is setup pivot and lay, and let's actually search for the references. Right. So this is the first reference that you have to replace, and I'll delete this one, and then we have another reference at here. So let's replace it using again local velocity direction. Right. Now remove this one. Yeah, and we have another one at here. This is basically the printing, right? But first let's play test again. Yep. Now forward to backward pivot works, and backward to forward also work, and left to right works, and finally right to left pivot also work. Okay, so now it seems that pivot issue has been resolved. Let's try the walk as well. Yeah. For walk, we have this pivot walk. So is it a root motion? Yeah, you root motion. Okay, that's fine. And let's try the crouch. Okay, forward to backward works, backward to forward works, left to right works, and right to left work. Okay, now I think that pivot issue has been resolved, and I'll remove these debug prints, compile, save, play it again. Yeah, seems all good. Right, so that's how we resolve that pivoting issue. So basically I added some bidirectional transitions as well at our anim graph. Locomotion inside pivot state machine, we have some bidirectional state machine implemented as well, because in case suddenly the pivotal changes happen based on these conditions, we can show the pivot again and it come back to the current state, right? And yeah, so those are the possible changes that we can do to fix this. But later on we'll see, when we add in new states, maybe we have to face different sort of issues as well. But yeah, for now I think this bug has been fixed. Okay, so thank you, see you there.